Okay, Assalamualaikum. Very good day to our lecturer, Dr. Fauzia Hanim, Binti Cik Seman. Today, I am from Group 5. My name is Jamal Rashid, and I would like to present our project entitled Electromagnetic Induction. As we know, the electromagnetic induction was found by Michael Faraday. Michael Faraday is the first English scientist that proved the magnet can create a current by move a magnet towards and away from the coil of wire that connected into galvanometer. From the experiment, he has observed that there is deflection in the galvanometer, indicate that the current is induced in the coil when the magnet is moved in out at the coil. As we know, electromagnetic induction will produce a phenomenon which an EMF or current that is induced in a conductor due to change in the magnetic field near to conductor is known as the electromagnetic induction. Let's do some experiment to prove that what Michael Faraday said is true. Okay, now for the experiment, that we need three basic things for the experiment, which is a solenoid, two solenoid which are made by ourselves. First equal to 100 turn and second equal to 200 turn. Second thing is a magnet. And third thing is a multimeter. Okay, now let's start our experiment with solenoid with 100 turns. First, we must set up the apparatus where the solenoid connect to the digital multimeter. Then we test it whether it have a connection or not. So there's a bus, they will have a connection in the circuit. Then we take a magnet and put it out and move into the solenoid. See, there's a reading on the digital multimeter. That is the induced current that produced from the magnet through the solenoid coil. The electromagnetic induction now can be found by observing the reading from the digital multimeter when the magnet is moved in and out at the solenoid. Different pole of magnet also will produce a reading in the digital multimeter, and also the change of number of the turn of the solenoid turn. When the magnet is moved in and out, it will show the reading at the multimeter that indicate the presence of current in the coil. when we use analog multimeter, it will also show the reading of direction of the flow current when we move the magnet in and out. Lastly, the speed of the speed of reading given at the digital multimeter also give the rate of which current is induced. Okay, now we like to do the experiment using a 200 turns coil of solenoid. First, we set up like before. Test the connection of the solenoid. Then we use a magnet to move in and out of the solenoid to get the reading. Now we would like to show another example in electromagnetic induction using only a solenoid and a battery to produce the electromagnetic induction, so that the solenoid will act like a magnet. First, we would like to solenoid, a battery, and a piece of stapler clip to show that the solenoid will act like the magnet. First, we connect. Okay, we begin the experiment. We take another clip into the magnet. First, we put this piece of stapler clip inside the solenoid first. Then we connect with the battery. Then now the clip all go to center, where the solenoid act like a magnet that attract the clip to attach with them. For our next example, we would like to light up this LED by only use the electromagnetic field that produced from the magnet and the solenoid. Actually, we know solenoid has its own magnetic field and magnet has its own magnetic field. Then we combine the magnetic field together. We produce a large induced current that would light up an LED. So this example would like to show the induced current that produced from two magnetic field that combine together. First, we need the DC supply to make sure the magnetic field current induce a large current that induce. So we put the solenoid into the magnet and we connect them with batteries. See, without contacting any LED, without contacting any it to the supply, just a magnetic field. The induced current produced will light up the LED bulb. And that's all for our experiment. So enjoy watching it, and thank you.